we'll see how helpful it is. But like I said, we're looking at synthetic division. Basically, this is a shortcut for long division when you're dividing polynomials. If you keep in mind what we've done throughout this week and a little bit last week, we've been looking at adding, subtracting polynomials. We've been looking at multiplying polynomials with like the box method. So we're going to look at division today. So keep in mind, this is like a very specific case. Some other types of division problems, you'll have to use long division, which can be a little bit more complicated. So I'm just going to kind of show you this synthetic division. So I'm not even going to read these steps because I think it will confuse you more. Maybe after we do a problem, maybe we can kind of look back at these steps. But I think the easiest way to learn synthetic division is just to kind of see it in action. So the first thing with synthetic division, and I don't know if you guys are with me in class, doesn't look like it, but whatever you're dividing by, you need to solve or figure out what would make this part equal 0. So x minus 4 equal to 0. If you solve this, it would equal positive 4. Or basically, whatever you're dividing by, you're going to do the opposite of it. So if it's a minus 4, you're going to have a positive 4 like in this top right, like in this little box here. So just for like, I know I'm kind of skipping to the next problem, but like, for example, since this is a minus 6, you would put a positive 6 in this box. Since this is a plus 3, you would put a negative 3 in the box. Basically, you do the opposite of what's inside that binomial. And we'll look at those when we get there. The next thing we're going to do is we're going to write our coefficients of what we're dividing into. So like the coefficients, remember, are the numbers in front. But pay attention to your signs. So like our coefficients would be 2 for the x to the third part. Our next coefficient would be negative 13. Our next coefficient would be 26. And our last coefficient would be negative 24. So you list your coefficients in like the order they come. It's kind of like with quadratic formula, if you remember when you found your A, B, and C. Same idea, except you might have more than just 3, like in A, B, and C. We have 4 terms versus 3 terms usually you see when you're doing quadratic formula. And I'm also going to just, above these, I'm just going to write what these were from. This was from an x cubed. This was the x squared. This was my x coefficient. And this was my constant, or just like my regular number part. So the first thing you're going to do is you're going to bring down your first number below this box. You just bring the 2 straight down. You're going to take your number inside this box and you're going to multiply it to this number you brought down. So 4 times 2 would be 8. Now we're going to add up this column. So if you have a calculator, negative 13 plus 8 would be negative 5. Now we're going to take 4 times the negative 5. 4 times negative 5 would be negative 20. Now we're going to add up this column. So 26 plus negative 20, that would be positive 6. And now we're going to take this 4 times the 6. 4 times 6 is 24. We're going to add up this last column. Negative 24 plus 24 is going to be 0. So sorry, I'm just going to kind of erase some of those arrows. This last box here is always going to be your remainder. I don't know if you remember dividing numbers way back in the day, you would get a remainder or not a remainder. So same idea here, your last box will always be a remainder. So in this problem, we don't have a remainder because we got 0. That basically means this divided into it evenly, like there wasn't anything left over. So you might be, so we're pretty much done with our synthetic division, but you might be wondering, well, what's our answer? Is it just 2, negative 5, and 6? We got to add one thing to it. Basically, when you divide this by this x, basically you're taking an x away from each part. So since this first part was x to the third, this is going to be an x squared part now. Since this part was an x squared, you're going to take away an x, so it's just like a single x. And then for this last part, since it was an x and you took an x away, basically it would just be no x's. So our final answer would be 2x squared minus 5x plus 6. Let me just pause this again. All right, so let's, in case you're still writing or if you missed something, like I said, I will I'm recording this and I will upload like what I have on this document to Google Classroom once I finish today. All right, so let's just look fresh at this second example. So we have x to the third minus 2x squared minus 25x plus 6 divided by x minus 6. So the first thing you want to do is figure out what's going to go like in this box here. What would it be? Not what's going to... It's the opposite of what you have inside this binomial. So since it's a minus 6, what's the opposite of minus 6? So you're going to put a positive 6 here. So like, for example, if you look at like the last problem down here, since it's a plus 3, you would put a negative 3 in here for like, just if that kind of helps you see. That's going to be like your first step. Figure out what goes in this like little box here. Okay, the next thing we're going to do is we're going to list our coefficients. So like what's in front of each one of our pieces. So, and keep in mind, if there's nothing in front, like the x to the third power, there's nothing in front. Remember, there's really a 1 in front of it. So we list our coefficients. So we have a 1, we have a negative 2 because it was minus 2x squared. We have a negative 25 because it was minus 25x. And then we just have a 6. We just kind of write the coefficients. It's like when we did quadratic formula, when you wrote your A, B, and C, you wrote like the coefficients or the numbers in front of the variable parts. Any questions so far? Okay, you're going to take your first coefficient, you're just going to bring it straight down. So that 1 comes straight down. You're going to take what you got in your box, so 6, times what we have down here. So 6 times 1 is 6. So that's what's going to go below the negative 2. So now we're going to add up this, like this column. We're going to add negative 2 plus 6. So if you're not super great with your mental math, you might want to use a calculator. But negative 2 plus 6, if you put that in, you will get 4. And then you're going to kind of keep this same process going. Now you're going to take 6 times 4. 6 times 4 is 24 if you need to plug it in or if you can do that in your head. But now we're going to add up this next column, negative 25 plus 24. If you plug that in a calculator, you're going to get negative 1. And then you're going to take 6 times negative 1. 6 times negative 1, if you plug that in, or remember when you multiply by negative 1, it just switches the sign. That's going to be a negative 6. And then if you add up this last column, you're going to get 0. 6 plus negative 6 is 0. And this last like box, this last number that you bring down, this is your remainder. So this problem doesn't have a remainder. That's what that means if you get 0. And you'll see most of the problems, if you are working on the Delta Math assignment later today or next week, you're going to see most of the problems you're not going to get a remainder. So you are going to get 0 in that last spot. So one thing I forgot to kind of write when I was doing this, remember this first part, this one was from an x cubed. This negative 2 was from our x squared part, right? This negative 25 was from an x, and the 6 was our constant part. When you divide by an x, basically, it's kind of like, if you remember, when you have x squared over x, basically you just take away one of the x's, right? So it's really the same idea here. When we divide this by x, basically each one of these powers goes down by 1. So like, so for our first part here, we had an x cubed, now it's going to be an x squared. This part here was an x squared, now it's just going to be an x. This part was an x, we took away the x, so now it's just like it's a constant, or there's no x part left over. And then this would be our final answer. So basically, when you divide by an x, you take away one of your powers from each, you take an x away from each one of these things. So I know that might be that might be where some of you guys might confuse a little bit. All right, and now we're going to look at our last problem. There's a lot, this one's got some things we got to be careful about. And honestly, some of the things in this problem you won't see in the delta math. So honestly, the first two examples we did are probably better to look at, but this is just some things to think about. One thing you got to be careful about with these problems, if you ever are missing part, like one of your degrees, like if you notice it goes from x to the fourth to x squared, it skips over the third power. So really what we have, this is really x to the fourth plus 0x to the third minus 10x squared minus 2x plus 4. Like, since it skips the x to the cube, you got to keep in mind when you write your coefficients, you got to put a 0 as a placeholder. So this is really what we'll be looking at when we write our coefficients. So like I said a little bit earlier, if you remember, it's the opposite of what's inside here. So since it's a +3, you're going to have a -3, like in our little square. We're going to write our coefficients. So our coefficient of our x to the fourth is 1. Because keep in mind, this is really 1x to the fourth. Our coefficient of our x to the third, since it skipped it, it's really 0. We don't have any x to the thirds. Our x squared's coefficient is -10. Our x coefficient is -2. And our constant is 4. And I'm going to write above those what those came from. So this was our x to the fourth part. This was our x cubed part. This was our x squared part. This was our x part. And this was our constant. So we're going to do the same process that we have then. We're going to bring this first coefficient straight down. So the 1 comes straight down. And now we're going to take what we got in our box and we're going to multiply it to this number. So -3 times 1 is going to give you -3. So you're going to add up this column. So 0 plus -3, if you put that in a calculator or work that out, that's going to be -3. And one thing, if you want to do this, I'll give myself a little bit more space. One thing, if you want, remember your powers are going to go down by 1. So this is really going to be x to the third power. This next part, like I said, it was -3. Since you had an x to the third power, it's going to go down by 1. So now that's going to be an x squared. So if you want to put in your x's as you go, you can as well. But now we're going to take -3 times -3. So the negative times the negative is going to be positive. So that's going to be a +9. If we add up this column, -10 plus 9, that's going to be -1. If you want, remember, it's going to take away an x. So x squared would just be a regular x now. And then we're going to take our -3 times -1. Negative times a negative is positive, so that's going to be a +3. You put that in your calculator, -2 plus 3. If you add up this column, you're going to get +1. And remember, you had an x, you took away an x, so it's just going to be a 1 by itself. And then lastly, we're going to do -3 times 1. We're going to get -3 here. If you add up this last column, that's going to be a 1. And this, remember, this last box here, this is your remainder. So this is the first problem we've seen this, but we have a remainder in this problem. I don't know if you remember way back to elementary school when you first did division, like by hand. Sometimes you would get remainders or you'd have something left over. Basically what that means is it's almost like if you divide a number and you get like a decimal, like 5.2 or 5 point something or 3 point something, that just means there's a little bit left over when you're dividing. So the last thing we would have to do, and this might be a little bit confusing, but when you have if you have a remainder, you're going to just keep the remainder and you're going to put it over what you divided by. So like you would put that 1 over x plus 3. And then that would be your answer. So if you have a remainder, you just put it over what you were dividing by in the original problem. And that's it. But this question here, honestly, is pretty tricky. Like, so there's a lot going on in this one compared to the first two. And I know there's a lot going on in these problems to start with anyways.